Let's start to apply those oxidation numbers that we learned about in terms of an actual reaction and decide who got oxidized and who got reduced. The first thing you need to do when you get a chemical equation or chemical reaction is assign oxidation numbers to the elements that you see. If you look at this, you recognize that this is a single replacement reaction. Remember, we said single replacement, combination, decomposition, and combustion can all be possibly redox reactions, but the double replacement exchange ones, no. All right. So this one could possibly be redox, but we have to see if it is, so we have to assign oxidation numbers. So let's first take a look at the magnesium. Remember, magnesium all by itself, oxidation number is 0. So we're going to go magnesium is 0. Okay, what happens to the magnesium over on this side? So on this side it was 0. On the other side, now it's part of a compound. It's part of an ionic compound. Magnesium's a group 2A metal. Its oxidation number is going to be the same as its charge. Its charge will never change. Remember, oxidation, group 2A metals are always +2, so +2. All right, so what happened to the oxidation number? The oxidation number went from 0 to +2. It went up. Remember the previous video, I said, if the oxidation number goes up, that means that substance was oxidized. So the magnesium was oxidized. Okay, why was it oxidized? Because it lost electrons. Now let's take a look at the hydrogen. Okay, the nice thing about redox reactions is that you can actually ignore the coefficients. It's the only time I'm going to tell you that you can ignore the coefficients. Okay, so just ignore the coefficients for our class. Don't worry about them. Just focus on the actual element. Coefficients are these numbers over here, remember. All right, so let's just take a look at the hydrogen. Hydrogen here is part of a compound. And it's a covalent compound. Remember the rule that said hydrogen is usually +1, so we're going to say +1. And then what happened to it over on this side? Now it's an element all alone by itself, not an ion, it's 0. So what happened to the hydrogen's oxidation number? It went down. So anytime the oxidation number goes down, it gets reduced, so we call it reduced. So the hydrogen's oxidation number went down because it gained electrons. So anytime an element is reduced, it's because it gained electrons. Anytime an element is oxidized, it's because it lost electrons. Okay? Now, it's at this stage where students will tell me, well, what about the chlorine? Well, once I've found the element that got oxidized and the element that got reduced, I can stop. I don't have to go any further because the others are not doing much of anything at all. If I assign a number to chlorine, this one chlorine is -1, and each, the key word is each chlorine here is -1, so -1 becomes -1, nothing has happened to it. So I'm just focused on these two guys. Now there's an added twist to this. Anything that gets oxidized is called the reducing agent. So whatever is oxidized is called the reducing agent. It's a little counterintuitive, but it actually does make sense because it is the agent of the reduction of the other element. So it is the reason the other element got reduced. So whatever gets oxidized, which is the magnesium, is also called the reducing agent. And whatever gets reduced is called the oxidizing agent. So whatever gets reduced is called the oxidizing agent. So in this case, the hydrogen was reduced, so it's the oxidizing agent. And because it's part of a whole compound, a lot of times they'll say the whole compound is the oxidizing agent. So it has an element in it that got reduced, and then we sometimes consider the whole compound as the oxidizing agent. Anytime on a quiz or test or review or anything where they're asking you for the oxidizing agent or the reducing agent, it's always going to be a reactant. It's never going to be a product. So on a multiple choice test, you might get all 4 of these, but you always just choose the reactants as the agents, okay? Let's try this one over here. Magnesium plus oxygen will give you magnesium oxide. This is a combination reaction. How do I know it's combination? Because I have one product. All right, so let's assign oxidation numbers. The magnesium on the left, all by itself, is a 0. Magnesium on the right, it's part of a compound. It's an ionic compound, magnesium oxide. The magnesium is a group 2A metal. Its oxidation number will be exactly the same as its charge, and the charge of the magnesium ion is +2. So we go from 0 to +2. All right. What happened to the magnesium? Magnesium's oxidation number went up. So here also the magnesium got oxidized. Okay. Now let's try the oxygen. Oxygen all by itself is 0. Over here, so magnesium went from this to this, and oxygen went from this to this. Here, oxygen is part of a compound. The sum of the oxidation numbers has to equal 0. This is +2, this is -2. All right, so what happened to the oxidation number of the oxygen? It went down, it went from 0 to -2, so it got reduced. So if they ask you, who's the oxidizing agent? You look at the reactants. Which reactant got reduced? That's the oxidizing agent. So this oxygen is the oxidizing agent. Why? Because it got reduced. And the magnesium is the reducing agent. Why? Because it got oxidized. Okay. The only way you guys are going to get really good at this is to practice, okay? Because if you don't practice and you just watch this video or some other video, then you hit the quiz or the test and you're looking at these options and you have no idea what you're doing, okay? So always practice assigning oxidation numbers, practice with the reactions, putting these oxidation numbers on the elements, deciding who got oxidized, who got reduced, who's the oxidizing agent, who's the reducing agent, you'll be all set. All right, so next video will be a completely different topic, I think, on our what we need to know list. Yep, we move right into collision theory. Okay.